Our solar system holds a celestial tale of two planets, a story of remarkable similarities and a starkly divergent present. This is the story of Earth and Venus, two planets that started their journey in the cosmos with striking resemblances but have ended up on vastly different paths. Welcome to Planetary Possibilities. My name is Aria. Venus, our closest planetary neighbour, bears a striking resemblance to Earth in size and mass. Both planets are nearly the same size, and their masses are quite similar, making them true cosmic siblings. Early in their formation, billions of years ago, these two worlds might have appeared as cosmic twins, each swathed in a veil of clouds, their surfaces potentially teeming with the nascent stirrings of life. They both had the potential to harbour oceans and perhaps even primitive forms of life. Yet today, a chasm of difference separates these once similar siblings. The paths they have taken could not be more different. Earth teems with life, its surface a vibrant tapestry of blue oceans, verdant forests, and icy polar caps. It is a planet rich with biodiversity, supporting countless ecosystems. Venus, on the other hand, is a scorching, hostile wasteland, its surface obscured by a thick, toxic atmosphere. The planet is shrouded in clouds of sulfuric acid, making it an inhospitable environment. The temperature on Venus is a staggering 462 degrees Celsius, hot enough to melt lead. This extreme heat is a result of a runaway greenhouse effect. What went wrong? How did these planetary twins diverge so dramatically? The answers lie in the complex interplay of atmospheric conditions, geological activity, and perhaps even cosmic events that shape their destinies. The answer lies in a phenomenon known as the runaway greenhouse effect. Venus fell victim to this process, transforming from a potentially habitable world into the inferno we observe today. The sun, though a source of life-giving energy, can also be a harbinger of destruction. As solar radiation bombarded Venus, its oceans began to evaporate at an accelerated rate. Water vapor, a potent greenhouse gas, accumulated in the atmosphere, trapping heat and further driving the evaporation process. This self-perpetuating cycle, a runaway greenhouse effect, caused temperatures to soar, eventually boiling away any remaining surface water. While Venus's present state paints a grim picture, whispers of a potentially more hospitable past are emerging from recent scientific findings. Data from NASA's Pioneer Venus mission in the 1970s, along with observations from later missions, suggest that Venus may have harbored oceans of liquid water for billions of years. These oceans, if they existed, would have significantly shaped Venus's early climate, and potentially even cradled the building blocks of life. However, the relentless onslaught of solar radiation, coupled with Venus's slow rotation, ultimately led to the catastrophic loss of its water. The once temperate planet transformed into the scorching, arid world we know today. The tale of Venus, though seemingly distant, holds a chilling relevance to our own planet. Earth is currently grappling with its own climate crisis, driven by the increasing concentration of greenhouse gases in our atmosphere. The very same culprit that doomed Venus, the greenhouse effect, is now threatening the delicate balance of our planet's climate. The burning of fossil fuels, deforestation, and other human activities are releasing massive amounts of carbon dioxide and other greenhouse gases into the atmosphere, trapping heat and driving global temperatures upward. The consequences are already being felt around the world: rising sea levels, more frequent and intense heat waves, and more extreme weather events. Scientists warn of potential tipping points in Earth's climate system, thresholds beyond which the consequences of climate change could become irreversible. The melting of the Greenland and Antarctic ice sheets, for example, could trigger catastrophic sea level rise, inundating coastal cities and displacing millions of people. The collapse of the Atlantic meridional overturning circulation, a major ocean current system, could disrupt weather patterns across the globe, leading to more extreme temperatures and altered precipitation patterns. These tipping points, though complex and difficult to predict with certainty, underscore the urgency of addressing climate change. Continued exploration of Venus will be instrumental in unraveling the mysteries of its past and gleaning further insights into the dynamics of planetary climates. Upcoming missions such as NASA's Veritas and Da Vinci Plus missions will provide unprecedented details about Venus's atmosphere, surface composition, and geological history. These missions hold the potential to revolutionize our understanding of Venus's evolution, shed light on the factors that contributed to its runaway greenhouse effect, and provide invaluable data for refining climate models here on Earth. By studying Venus, we are not just exploring another world, we are deepening our understanding of our own. To truly understand the fate of Venus, we must delve into the atmospheric composition of this enigmatic planet. Venus is shrouded in a thick veil of carbon dioxide, making up over 96% of its atmosphere. This dense blanket traps heat through a runaway greenhouse effect, causing surface temperatures to soar to an average of 467 degrees Celsius, hot enough to melt lead. The clouds that obscure Venus are laden with sulfuric acid, creating an environment that is both hostile and uninhabitable. These conditions have led to a surface pressure 92 times greater than that of Earth, crushing anything that attempts to land on its scorched terrain. The extreme atmospheric composition not only shapes the planet's climate, but also serves as a dire warning. It illustrates the devastating potential of unchecked greenhouse gases. As we look to Venus, we are reminded of the delicate balance required to maintain a habitable world. The lessons from Venus are clear. Our atmosphere is our lifeline, and its preservation is paramount. With this knowledge, we can better appreciate the fragile beauty of our own planet and the urgent need to protect it. Venus stands as a testament to the consequences of atmospheric imbalance, urging us to act before it is too late. Our fascination with Venus dates back to ancient civilizations, but it wasn't until the advent of space exploration that we began to peel back its veiled mysteries. The first successful mission to Venus was the Soviet Union's Venera 7 in 1970, which became the first spacecraft to transmit data from the surface of another planet. Despite the harsh conditions, Venera 7 managed to send back critical information about Venus's atmosphere and surface temperature before succumbing to the extreme environment. Subsequent missions, such as NASA's Pioneer Venus project and the Soviet Union's Venera series, continue to unveil the secrets of our celestial neighbor. These missions provided us with detailed maps of Venus's surface, revealing vast volcanic plains, towering mountains, and evidence of tectonic activity. The Magellan mission in the early 1990s revolutionized our understanding of Venus by using radar to penetrate its thick clouds, offering unprecedented images of its surface. These findings confirmed that Venus is a dynamic planet with a complex geological history, marked by volcanic eruptions and shifting crustal plates. More recent missions, like the European Space Agency's Venus Express, have focused on studying the planet's atmosphere, shedding light on its chemical composition and weather patterns. These missions have been crucial in understanding the runaway greenhouse effect that has transformed Venus into the hellish world we see today. Each mission to Venus has brought us closer to understanding not only the planet itself, but also the broader mechanisms that govern planetary climates. The data collected from these missions serve as a stark reminder of the delicate balance required to maintain a habitable world. As we reflect on the data collected from our missions to Venus, a sobering question arises. Could Earth one day mirror the fate of Venus? The parallels between the two planets are striking. Both began with similar sizes, compositions, and positions within the habitable zone of our solar system. However, the paths they took diverged dramatically due to the runaway greenhouse effect that now dominates Venus. Venus's atmosphere is a toxic blend of carbon dioxide and sulfuric acid, with surface temperatures hot enough to melt lead. This hellish environment serves as a grim warning of what could happen if we fail to address the escalating climate crisis here on Earth. Scientific models show that unchecked greenhouse gas emissions could push Earth's climate toward a tipping point, creating feedback loops that could make our planet increasingly inhospitable. Rising temperatures, melting ice caps, and extreme weather events are just the beginning. The lessons learned from our exploration of Venus emphasize the urgent need for climate action. By investing in renewable energy, reducing carbon emissions, and protecting natural ecosystems, we can mitigate the worst impacts of climate change. The future of Earth does not have to be a mirror image of Venus. Venus isn't just a distant planet, it's a mirror showing us Earth's potential future. One small change, one tipping point, can transform a living planet into a lifeless inferno. If you enjoyed this video, be sure to like and subscribe to stay up to date on all planetary possibilities.